Today we'll talk about the trigonometric functions of acute angles. So first we're going to grab an acute angle and we'll label it theta for us to be generic. So theta can be any acute angle. And then I'm going to create a right triangle for us to work with. And as we know from geometry, if the angle stays the same there, any right triangle that we're going to create are going to be similar to each other. So if we pick any of the sides to see what the scale factor is, that scale factor will stay consistent. And we're going to take one of those triangles and we're going to label the sides. So first of all, because it is a right triangle, we have the longest side, which is the hypotenuse. So we'll label that first. And then if we think about this angle, the side that is opposite of that angle, we call it the opposite side. And then the only side that hasn't been labeled yet is called as the adjacent side. So these are the three sides of a right triangle with an acute angle that we're focusing on. And then we can formulate our trigonometric functions. So each of these functions is a ratio of the sides, and depending on which one you're using in which order, that ratio is labeled a different trig function. So the first one that we'll look at is sine, and because we need the angle, we call it sine of the angle. So sine theta is equal to, and sine is going to be opposite side over hypotenuse. And if we look at cosine, cosine also uses hypotenuse on the denominator. But for cosine, it is adjacent over hypotenuse. And the third one that we'll look at today is tangent of the angle is going to be the opposite over adjacent. So another way to look at tangent is going to be sine over cosine. For example, if we had a triangle that has two sides, so if this was our theta and we knew that this was 3 and the hypotenuse was 5 and we don't know the opposite, and suppose we had to find sine, cosine, and tangent of theta for this triangle. So the first thing that we have to do is find out what the opposite side length is. So in order for us to do that, we are going to go back to geometry where we learned about Pythagorean theorem. So Pythagorean theorem states that if you create squares, and excuse my drawing, if you create squares for each of the sides, if you find the area of the two smaller squares and add them up, it'll equal the hypotenuse squared. So using that, if we have 3 squared plus, and we don't know, opposite squared is equal to the hypotenuse squared, so 5 squared. And because we want to solve for this question mark, what we're going to do is subtract 3 squared from both sides. And so we have question mark squared is going to be 5 squared, which is 25, minus 3 squared, which is 9. So we have that this question mark, which is the opposite side, squared, is going to be equal to 16. So that means the opposite side has to be 4. So now that we have each of these numbers, what we can do now is find the sine, cosine, and tangent of theta. So first, if we look at sine of theta, we can look back here, it's the opposite over hypotenuse. So for us, opposite is 4, hypotenuse is 5. So sine of theta is 4/5. And then cosine of theta is going to be adjacent over hypotenuse. So while the denominator stays the same, the numerator is now going to be 3. And then finally we have tangent of theta is going to be the opposite over the adjacent. So it'll be 4/3. And earlier I mentioned that tangent is sine over cosine. So the reason why I mentioned that is if you do sine, which is 4/5, over cosine, which is 3/5, and because it's a fraction over a fraction, we can think about this as the big division. So if we instead write the division as multiplying by the reciprocal, we have this, and then the 5's will cancel out, and we'll have 4/3, which is exactly what we had for tangent. So although for this example, it was easier for us to find tangent theta as opposite over adjacent, there will be some situations where doing sine theta over cosine theta will be the easier route. So just to have that in our tool bag for us to use later, and to know why that is true from the start.